Okay, we're talking about general solutions. All right, we understand we do have two different units. One is radians, the other one is degree. Right, and so we start from 10. So general solution for 10 will be whatever the angle you're looking for should be equals to n pi plus theta. That can be written slightly different, but what you understand is this is the angle you're looking for, right? The solution you're looking for. And this is one solution, particular solution. Yeah. So if you add any periods or minus any periods, and it tends to be a general solution, right? So hence, n pi is over there. So you can also turn into degree. So alpha in terms of degree, that will be equals to pi is equivalent to 180 n and plus whatever theta in terms of degree. Okay. Okay, so that's 10. And then last lesson we done cosine as well. So this angle should be equals to 2 pi n plus or minus whatever the angle that you have as a one solution. Okay, so if you turn it into degree, that will be 360 degree times n, that's degree, and plus or minus one solution. Okay, one particular solution. Okay, so far so good. You understand that? Okay. All right. Just remind you what's going on for the cosine, right? So this is a cosine what it used to be. We understand if over here you have the periods, which is 2 pi, you can actually plus to get answer. You can also minus the same amount to get answer. Okay, either way is okay. Hence we say plus or minus. Okay, plus or minus. All right, now we're gonna have a look at sine. Rather actually I draw it out. It's good actually if I use this. See whether we can get this going over there. Just give me a second over here. All right, so I'm gonna put the screen over there. Oops. Sorry. Okay. Or just make it easier, sorry, just so that you can see it clearer. All right, this is sine wave over here. And we have y equals to sine, whatever this angle is, x. Now I turn the x scale into pi units, and so that you can see how many pi is going to be, right? We understand the periods over here is going to be 2 pi, okay? Now, if we have an equation, say y equals to, sorry, sine x equals to half. Okay. Now, what is the general solution for this equation? Now, for this one, this is half. The blue line represents y equals to half. So if we understand where the intersection point, that will be the solution for this equation. So we understand we have lots of solutions, right? Not just one. So let's have a look and how do we solve that in terms of general solution, right? So we understand sine x equals to half. We understand x will be equals to inverse sine half. Right? If you use a calculator, roughly you understand that's give you 30 degrees. That's pi over 6. Okay, pi over 6 over here. So we only find out from calculator one solution. But how do you actually to describe all of these solutions? Since this is going to be a solution as well. So what do you think this one is going to be? So this is pi over 6. What is this one going to be? Now, because it's symmetrical, which means this portion should be same as this portion, right? So both are going to be pi over 6. So hence, for this point, there will be pi take away pi over 6. That give you 5 pi over 6. Should I write down pi take away pi over 6? Does it make sense? Now, if you have a look at this is pi over there, and this is 2 pi, that's fine. What is the next solution? Well, it seems like that part is also pi over 6, which is precisely just the first particular solution we'll find out. So hence this one should be equals to 2 pi plus pi over 6. Okay, all right, just follow the thoughts over here. If I look for the next one, if I draw it out, this is also a solution over here. That give me roughly this value. Now I do understand this portion because it's symmetrical. So all of this yellow highlighted ones should be all pi over 6. Now for this one, there will be 3 pi minus pi over 6. Okay, so far so good. All right, so hence we understand we not just have pi over 6 as a solution, we also have pi minus pi over 6 and 2 pi plus pi over 6, also 3 pi minus pi over 6. This list is unlimited, going either way. Okay. How we can actually express this in the general form? All right, let's have a look. Anything we can do over here. Now, that's 3, that's 2. So naturally, we say this is 1 over there. And the next one, there'll be 0, right? So this is 0 pi. I can add over there, that's fine. So I try to see whether there's any pattern, right? So if I say n is really an integer over there, the general solution, which is x, should be equals to n pi. Yeah, that's the first part, n pi. Yeah. When n equals 0, that's n pi. And then when n equals 1, 1 pi, 2, 2 pi, 3, 3 pi. That's fine. Okay, the first part. And then what is the second part going to be? Second part, when n is equals to 0, that gives us positive. When n is equals to 1, that's negative. When n is equals to 2, which is 2 pi, it's positive. When n is 3, it's negative. Is there any pattern? Yeah, seems like 1 is even number. It gives us positive. 1 is odd number. It gives us negative. Now, hence there's the trick. It's called a sign changer. I think that's what in the book can call sign changer. So we can do this. We can do this. All right, we can put a negative 1 over there. And then raise to certain power. Since this one, when n is equals to 1, sorry, 0, that's 0 pi, and plus is going to be changed to plus negative 1, the bracket raised to the power of 0. What is negative 1 raised to the power of 0? They give you 1, right? And then when n equals to 1, if the power changed to 1, negative 1 raised to the power of 1, I give you negative 1. Cool. Now, if negative 1 raised to the power of 2, for this case, when n equals to 2, let's give you 1. It's positive. Excellent. So hence, we can conclude we can actually plus a negative 1 raised to n power, and then times that whatever the first solution is going to be, right? So hence, that will be the general form that we can have. All right. In case of a particular solution, where's everything over there? All right. Okay. Now, in case of particular solution, we say, okay, now if we have sine over here, if I know a particular solution, which is theta, it should be equals to n pi plus negative 1 raised to nth power. That's it, right? Now, if we have degree, that will be equals to 180 degree times n and plus negative 1 raised to nth power and then theta degree, okay? Where theta is one solution, where n is belong to the integer, right? So that's everything that we cover so far for general solution. That's everything, okay? That's everything covered so far. Let me give you one example over here to see what's going on there, right? All right, let's have a look one example. So if I say sine, sorry, let me see. Sine theta equals to, what's it going to be? Sine theta equals to square root of 2 over 2. All right, can you find out a general solution? Okay, now let's find out one solution. Theta equals to the inverse sine bracket square root of 2 over 2, bracket finish. That give us a solution, which is 0.785. Okay, if you're quick, and you probably understand this is also 45 degree. Okay, pi over 4. Now, okay, that's one particular solution. Now, based on general solution form, theta should be equals to n pi plus -1 raised to nth power in time this general solution, where n is an integer. Okay, so that will be the general solution that we have. Okay, let me actually pause the recording over here.